Now see the cyclotron. Cyclotron is a device which is used to accelerate charged particles like protons, neutrons, etc. Here in case of the cyclotron, we can accelerate the charged particle by passing it through the electric and magnetic field both repeatedly. See here, electric and magnetic field both are acting here perpendicular to each other, that is called the crossed electric and magnetic fields. So now see, how does this device work and what is its working principle and what are its frequencies and energy of the charged particle. So now see, suppose there is a magnetic field taken here in this way. So, this magnetic field is actually emerging out of the plane of the paper, dotted line I am taking. So, that means emerging out of the plane of the paper. There are two D's used here, big here D's, and these D's are like this. This is called D1 and this is here D2. So, we can take D1 and D2 are two D's. These D's are connected to here oscillator. Oscillator is here actually used to apply the voltage here and its direction can be changed. And now what happened here in this case? Suppose you have placed any charge particle, charge ion at this point. This is a charge Q positive ion is placed here. And in this case first one, D has got the negative polarity with the help of this oscillator and D1 has got positive polarity. So, because of this negative polarity, this positive charge will be accelerated to this side. As this charge enters into the D, electric field becomes 0 because it is made of the metal, that is a conductor. So, inside the D electric field is 0. So, this charge experiences only magnetic field inside the D. Because of the magnetic field, this charge follows semicircular path. As charge comes into the gap, again the polarities of the D's are changed. Now, this will become D1 will become negative and D2 will become positive. Again this charged particle will accelerate here, it means its velocity will increase in the gap. When the charged particle comes in between, again inside the D, electric field is 0. Now, the charged particle will be going with the larger radius inside the D1. By this way, charged particle keeps on moving like this is here. And whenever the charged particle gains enough energy, hereby there is an exit window here is used, that is called exit window, and with the help of this exit window, charged particle can be taken out and it can be made to strike the target. So, see here, by using crossed electric and magnetic field, we can increase the kinetic energy of the charged particle by passing it through both the field repeatedly here. So, but it is important condition is here, whenever the charged particle reaches into the gap of these two D's, the polarities of the D's has to be changed at the same time. Otherwise, the charged particle will collide here and there or with the walls of the D's and it will not be able to perform the circular path. So, it is necessary to get the charged particle in the gap when the polarities of the D's are changed. So, now let us see its mathematical concept. So, now see, when the charged particle is moving in the semicircular disk or you can say in 1D, it is performing semicircular path. In the semicircular path, its time period can be written here. This is here T by 2 is equal to, time period is equal to 2 pi m upon here, this is only pi m for the semicircular path upon here QB. So, we can take this is the T is the total time period for the circular path. So, we have taken it is for the semicircular path. So, this is half of the time period, that is pi m upon QB, and we can write here T is equal to 2 pi m upon QB. And frequency can be written nu c is equal to QB upon 2 pi m, that is the reciprocal of the time period. This frequency is called cyclotron frequency. So, here this we call it here cyclotron frequency. So, in the cyclotron frequency here, when this frequency is equal to the frequency of the applied voltage, so we can write Va is equal to nu A is equal to nu C, that is the cyclotron frequency is equal to the frequency of the applied voltage, then we call the cyclotron is in the resonance condition. So, that is for the condition of the resonance. And also here, when the charged particle is moving in the circular path and its speed keeps on increasing, that means kinetic energy keeps on increasing. Then we can calculate also its kinetic energy by calculating its speed. So, now see here, suppose the maximum radius of the circular path is suppose r naught, then we can write its maximum velocity r naught is equal to mv naught upon qb. Here v naught is the maximum velocity. So, we can write v naught is equal to qb r naught upon m, and then maximum kinetic energy can be written here half mv naught square, and this is here half m into q square b square r naught square upon m square. This will get cancelled. So, you will be getting q square b square r naught square upon 2m. So, this is the maximum kinetic energy of the charged particle in the cyclotron.